standard form of the quadratic. Just like how we learned about linear equations and how they have multiple forms, quadratics can be represented in different ways as well. Similar to slope-intercept form for a linear function, the standard form of the quadratic function makes graphing easy. This is because we can quickly spot the vertex and which way the parabola opens. This means that a quick sketch can reveal how many x-intercepts the parabola will have. So let's attempt to sketch f of x by first converting it to standard form. As I go over the steps, we will work through the following example. We are going to do this by completing the square. So make sure that you go back and review completing the square. We're going to do it in 5 steps. Step 1 is to group the variables. I'm going to place them in red brackets, and I will be focused on completing the square of the terms inside those red brackets. Note that the constant term 4 is outside that grouping and is thus pushed to the side. We will now factor out the leading coefficient a from this group, just from the terms inside the red brackets. Step 3. This is where things get tricky. We know that if we just had b over 2a squared, factoring would not only be quick, but it would factor as a perfect square. That is, both terms would be the same. But we don't have two sides to the equation. So let's focus on that group because that's the part we're trying to square. So I'm going to push everything else to the side here. What we would really like is to have that b over 2a squared term. But again, I can't just add b over 2a squared and replace the x squared minus 2x. They would not be equal. So instead, I have to not only take the negative 1 squared in blue, the part that I want, I will have to also take away the negative 1 squared, the part in yellow. You'll note that those two would cancel out, so now we're not changing the value of x squared minus 2x. So I will replace the x squared minus 2x with x squared minus 2x plus the negative 1 squared minus the negative 1 squared. Let's clean things up just a little bit. We need to get rid of the yellow negative 1. We didn't want it in our group in the first place. As it is in the curly brackets, according to the order of operations, it is waiting to be multiplied by 3. So when I remove it from the group, I have to multiply it by that negative 3. So a negative 3 times the 1 comes out of our group. Reduce that a little bit, that's negative 3. So step 4, we're just going to factor and combine. We're going to combine the constant terms on the outside first. Negative 3 plus 4 is a positive 1. Now, let's return our attention to the bracketed group. The whole point of what we did earlier was to get it to factor perfectly. It factors perfectly as x minus 1 squared. Check your factoring. Make sure to multiply x minus 1 squared back out to ensure you factored correctly. Factoring is only going to play a larger and larger role moving forward, and you want to catch any mistakes as soon as you factor, instead of waiting to the end of the problem. Now, here we can check and see what we've done, and you'll note that going this way is way easier. Just follow the order of operations and multiply it back out. And we can see that the standard form we've created is equivalent to the form we started with, or the original form that we had. We're back to our original function. I will often collect my thoughts in these, I call them all work boxes. So we got it in standard form now. Now we're ready to get our results. The vertex will be 1, 1. Be careful. Looking at the standard form, you can see that it's a negative h, but a positive k in the formula. As a is positive, it's a 3. We will say the parabola opens upwards. A quick sketch will reveal that this quadratic will have no x-intercepts.